Okay, now we're going to learn another way to find the x-intercepts. If we can't factorise, then we're forced to complete the square. Now, to complete the square, you need to add on half the coefficient of x. Now, what that means is coefficients. The coefficient of x squared, with this example, would be 1. It's what's in front of the pronumeral. In front of x squared is 1. The coefficient of x squared is 1. The coefficient of x is minus 4, because minus 4 is in front of that. And this is the constant term, 1 over here. Okay, so if we are to factorise this, we can't do it, because if you try to put it into the two brackets like this, x times x, and you're trying to get 1 times 1, there's no way of getting outers and inners to be minus 4. So we can't do it. So we complete the square by adding on half the coefficient of x. So we add on half of minus 2, minus 2 squared, and take off minus 2 squared. Now, you don't have to have minus 2, because you're squaring it, it's going to be positive. But really, half of minus 4, you really got plus minus 2 squared and minus 2 squared. Now, the reason we do that is because these first three terms will actually be forced to be a perfect square, which is this one here. At the end, we got these two numbers, which is this number and this number here. We just keep sitting at the end. So now we've got it in what's called the vertex formula, which we saw in the video before, where you can read off the vertex, and the vertex is 2, minus 3. We can also get the x-intercepts from this. The x-intercepts is where it cuts the x-axis when y is 0, and we could easily take 3 over the other side, square root it, and take 2 over, and we've got the x-intercepts. And I'll show you how to do that with some of these questions down below. So we'll do exercise 1D. X squared take 2x plus 3. So y equals x squared take 2x plus 3. Okay, first thing to do is, well, if you try to factorise it, you realise you can't. So you go x times x, 1 times 3, and we can't get minus 2. You can get outers and inners giving minus 2, but then you get the product of minus 3, and we got plus 3. So there's no way of doing that. So instead, we add on half the coefficient of x squared. So if you add on half of minus 2, half of minus 2 is minus 1, so we're going to add on minus 1 squared, but we're going to take it off, so we don't change it, and we still got a plus 3. Now, grabbing those first three terms, we can get a perfect square, x take 1 all squared. And we've got the remaining numbers over here, which is minus 1 plus 3, or x take 1 all squared, minus 1 plus 3 is plus 2. Now, that's in vertex form, so the vertex is 1, 2. In other words, the graph would look like this, 1 across and 2 up. Because we've got a positive a, it's a smiley face quadratic, so it's sitting there. Vertex is 1, 2. If you wanted to try and find the y-intercept, that's when x is 0. So if you put 0 there, you have 0 take 1, which is minus 1 squared, which is 1. 1 plus 2 is 3. So we know that the y-intercept is 0, 3. If you wanted to find the x-intercepts, and it's clear from this that there are no x-intercepts, but sometimes there are, to do that, you would have to put y 0, in which case you'd be solving this. When y is 0, what are the x values? So we take 2 over the other side, which is minus 2. Now we have to get rid of the square, so we square root both sides, and when you square root, you put plus or minus times the square root, and you can see now we've got a square root of a negative number, and that's why we don't have any x-intercepts. If that was a positive number, we'd take the 1 over, and there are our two answers, 1 plus or minus the square root of minus 2. Clearly you can't have square root of a negative number, so we must say no solution. Later on, we're going to learn that we actually call this an imaginary solution, because we can make that in terms of I, but we'll see that in a later video. Okay, so back to 1D. You can try the remaining of 1D. And here are the answers to 1D. So there's question 1 we did with the vertex 1, 2, B, C, D, E, F. Now sometimes it's a little bit harder. Notice all of these have 1 in front of the x squared. The coefficient of x squared is all 1. When it's not 1, it's you have to take it out as a common factor. So we're going to do 2. There's a worked example here. See how it's got 3, and they take 3 out as a common factor. Right, so to do question 2, we're going to use 2x squared plus 4x plus 5. Notice this one's asking you to complete the square, state the vertex, find the y-intercept, and graph it. So 2x squared plus 4x plus 5. (2x squared plus 4x plus 5). Okay, so first of all we need to take 2 out as a factor. So if we take 2 out of that, it's x squared plus 2x plus 5 on 2. So we've got to deal with fractions. We can only use completion of square when you've got 1 in front of the x squared. So now we go x squared plus 2x. We add on half the coefficient of x, which is plus 1 squared, and we've got to take it off, and we've still got our 5 on 2. Now we can branch those 3 terms into the perfect square, which is x plus 1 all squared, and we've got our minus 1 plus 5 on 2. Now we'll tidy those fractions up. Minus 1 on 2 is minus 2 on 2. So minus 2 on 2 plus 5 on 2 is 3 on 2. And so that's our quadratic. We could actually now multiply the 2 through if we wanted to, and we'd get 2x plus 1 squared. And when you multiply the 2 by the 3 on 2, you'll get 3. So now we can see that the vertex is minus 1, 3. So the graph would look like this, minus 1 and then up 3. So I'd be sitting there. It's positive a values, so it actually comes down and comes back up like that. Once again, you can find the y-intercept there by putting 0. If you put 0 there, you'll have 1 squared times 2. That's 2 plus 3 is 5, so that's 0, 5. And the vertex is minus 1, 3. Okay, so now you can have a go with the remaining of 2. And so you don't need to do all of them. They've got highlighted E and F, probably because there's a negative, so you just take the negative outside, and this would you'd take a negative 2 outside. Okay, pause it and try those. And here's the answers to 2. So you've got first one, minus 1, 3 vertex, and then you've got B, C, D, E, and F. Okay, now we'll actually find the x-intercepts. I briefly mentioned it in question 1. We'll do it in detail now. This is what they call quadratic equations when the y becomes a 0. We're trying to solve for the x-intercepts. We've already had practice at factorising. When it can factorise, when that equals 0, you can see that you just factorise it and one of the 2 brackets is 0. You can make them both 0 and get the x-intercept. This one here, x squared equals 5x plus 6. You factorise that. So you read off the first factor, x equals 6, second factor, x equals minus 1. But we're going to do it for the completion of the square. So Let's go down to question 2. We'll solve some of these. So x squared, take 4x plus 1. X squared, take 4x plus 1. Normally we have that as a function, but we're finding out the x-intercepts, so now it becomes an equation. So we're solving this equation. We've got to use completion of square because we can't factorise that. So it's x squared minus 4x plus half the coefficient of x. Half of minus 4 is minus 2, so we add on half of that squared, and we take off half of that squared, and we still got a plus 1. All of that there will give you your perfect square, which is x minus 2 all squared. And these numbers is minus 4 plus 1, which is the same as x take 2 all squared minus 3. Now what we do, we stopped there before we just said the vertex was 2, minus 3. We're going to find the x-intercepts, which means we're going to solve it when y is 0. So we take 3 over the other side, and we get 3 equals x take 2 squared. Now we've got to square root both sides, so x take 2 equals plus or minus the square root of 3. And if we take 2 over the other side, then we've got our answer, 2 plus or minus root 3. So that now tells us that if we were to sketch that function, we've got a vertex of 2 here, 2, minus 3, so 1, 2, 1, 2, 3, so it's down here. And it's a smiley face, and so we have a graph that's coming down, turns there and comes back up. So this x-intercept here is actually 2 plus root 3, and this x-intercept here is 2 minus root 3. So completion of square has given us x-intercepts, vertex. You could also get the y-intercept by putting x0 into there. If you put 0 into this x, or even up the top there, it can be any one of these. Put up the top, that'll be 0. That'll be 0, that'll be 0, so you get y equals 1. So that's 0, 1. So we've got all key points of the quadratic on the graph. Okay, so you try and find the x-intercepts or solve the equation for 2. And here are the answers to 1E2. Question 2. There's 2 plus or minus root 3 that we did, and there's the others all the way down to I.